Hello and welcome to Science with John. Today we will be starting chemistry, the awesome study of, among other things, substances, their composition, and their behaviors. Now, to begin, we first need to understand some key concepts that will enable you to grasp much more complicated ones in the future. Let's start with what's called matter. You've probably heard of that term before, but have you ever set out to define it? Matter is defined as anything that has both a mass and a volume. Let's check out a few examples. A tree, your phone, even the entire planet is matter. Now, you might have realized that it seems that matter is basically anything, but no, it's not. Gravity, for example, is it matter? Well, does it have mass? No. Does it take up space? Can you fill up a box with gravity? No. Gravity is thus not matter. Gravity is actually a force. Now that we understand what matter is, why not analyze it? From the surface, different types of matter seem unique. A tree and your cell phone don't really have too much in common. That said, if you zoomed in a lot, and I mean like a lot, you would notice something similar between all matter. It's made of these little spherical things that are called atoms. Of course, you've never seen a singular atom before because they are incredibly small. Even just a glass of water contains an uncountably large amount of atoms. By now, you might have realized the problem. If all matter is made of atoms, then why do different examples of matter seem unique? The thing is that there are not only different possible arrangements of atoms, but also different types of atoms. We'll talk more about that later, but let's first take a closer look at a singular atom. Here we see that this singular atom is made of different parts. We see three major components. The red dots are called protons. The green dots are called neutrons, and the blue ones are electrons. Now, please note, these aren't actually colored like this in real life. I'm just using them to represent them. Now, all these dots are what we call subatomic particles. And so, to summarize, you know three types of subatomic particles: protons, neutrons, and electrons. Now, something very interesting about these particles is that they each have a different electrical charge. Neutrons, whose names start with the first few letters of neutral, have a neutral charge. Electrons have a negative charge, and protons have a positive charge. Simple. Three subatomic particles, protons, neutrons, and electrons, and three charges: positive, neutral, and negative. Now, knowing the charges of these subatomic particles, we can determine that the atom in my diagram is neutral. How? Well, we count 2 protons, 2 electrons, and 2 neutrons. Well, the neutrons have neutral charges, so they don't really affect anything. But the positive and negative charges cancel each other out. This means that my atom is neutral. In fact, all atoms in their natural state are neutral, meaning that they have the same amount of protons as electrons. The amount of neutrons that an atom has, again, doesn't really matter to the charge of the atom because they have a neutral charge. In my diagram, we see that I have 2 of each kind of subatomic particle, but not all atoms have the same number of each. In fact, it is the number of protons that an atom has that determines which kind it is. In a future lesson, you'll see why it's not the amount of neutrons and electrons that does that. So, returning to our previous examples of matter, these different kinds of matter are made of different kinds of atoms or elements. The different elements being composed of atoms with different amounts of protons. Now that we know this, let's talk about how atoms are organized. If we go back to my diagram here, you see this rather large clump of subatomic particles. This clump is called the nucleus. Then when we look at the electrons, we see that they orbit the nucleus, they go around it. And something very interesting is that the first ring of electrons will have a maximum of 2. And then any rings after that have a maximum of 8. So let's look at an example. Here we see an atom of boron, which has 5 electrons. So the first ring, again, has a maximum of 2. 1, 2. We have 3 left to go, so the outside ring has 3, which is within the limit of 8 electrons. 2 on the inside, 3 on the outside. A very special ring of electrons that an atom has is called the valence shell, which is the furthest ring of electrons of an atom. Knowing the amount of electrons on the valence shell is extremely important to know how an atom will react to others, and we'll talk about that later on. To determine how many electrons an atom has on its valence shell, you can just count, remembering that the first ring has a maximum of 2 electrons, and that rings after that have a maximum of 8. So this boron atom with 2 on the inside, 3 on the outside, has 3 valence electrons. Let's look at another example. Phosphorus, which has 15 electrons. We see we have 2 on the inside, the maximum of 2. This ring, which has a maximum of 8, so now we have a total of 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That leaves 5 on this outer ring. So phosphorus has 5 valence electrons. Now all of this serves as a really good base to begin to dive into the world of chemical reactions, and will, as I said, enable you to grasp much more complex ideas in the future. Now finally, before we go, let's make sure you've understood everything we've talked about. Feel free to pause this video on this screen and to write your answers down to these questions. I'll show the answers later. Anyways, thanks for watching this episode of Science with John. Goodbye.